In this problem we are asked to calculate the current through this 12 ohm resistor, but we are asked to use the source transformation technique. See, the 12 ohm resistor is connected between these two terminals. Let's denote this terminal with terminal A and this terminal with terminal B. So while we are applying source transformation theorem, we cannot touch this 12 ohm resistor and we have to reduce other elements to only a single or two component. See, if this is terminal A, this is terminal C, this is terminal A and this is terminal C, I will see that this will also be A, this will also be C, this is also be A and this is also C. See, between the terminal A and C we have two current sources are connected in parallel. So as they are supplying current in the same direction, these two will give us a current source in upward direction of 11 ampere and other circuit will remain as it was in our previous circuit. Okay, this is our terminal A and this is our terminal B. Between terminal A and B we have a resistance of 12 ohm. Between the terminal, sorry, this is not our terminal B, this is our terminal C. If this is our terminal B, between the terminal B and C we have a resistance of 3.33 ohm and a current source of 3.6 ampere. Now look at the terminal A and C and B. If this is terminal C, this will be also terminal C. Now we will see that we have a current source with a resistance of, sorry, this resistance will be 9 ohm. We have a current source with a resistance which are in parallel. That means I can reduce these two into a voltage source and a resistance in series. Now at the same time look at the terminals B and C. We will see that we have a current source of 3.6 ampere in parallel with 3.36 ohm. That means we can reduce these two. We can reduce these two into a single resistor, into a voltage source and a resistance in series. Let's convert. This is our first simplification. In our second simplification, as current is flowing in this direction, therefore positive side of the voltage will be upside and resistance will be in series. The value of resistance will be equal to 9 ohm and the voltage source and the resistance will be in series between the terminal A and C. Okay, now I look at the here we have terminal B and terminal C. See, in this terminal we have a current source of 3.6. See, the current source is supplying current in upward direction, therefore the positive terminal of the voltage source will be in upward direction and the resistance will be in series with it and the value of resistance will be 3.33 ohm. This is our terminal B and look, we have a resistance of 12 ohm in the between A and B. This will give us our second simplification. Now what will be the value of this voltage? See, we have a current source 11 ampere and a resistance of 9 ohm. That means here we will get Vs equal to source current into resistance. Here we have 11 into 9, that means it will be equal to 99 volt. Now see here, we have a in case of this voltage source voltage will be ISRS. Here we have a source voltage of 3.6 ampere and resistance of 3.33 ohm. Therefore this source voltage will be equal to 12 volt. Okay, and see, if we look closely, we will see that this is our voltage source is in series with this voltage source, sorry, this resistance, and all these three resistances are in series. See, this voltage source 99 volt is supplying current in this direction, and this voltage source is supplying current in this direction. So in this series circuit, resultant current will flow in this direction, in clockwise direction. Okay, let's say that current is I, and that same current will flow through this 12 ohm resistor. Now why do I have to do this? To find the current through this 12 ohm resistor, as this is our series circuit, so total current will be same, but before calculating the current, I have to find which voltage source is providing more current. See, this is 99 volt source and this is 12 volt source. That means the source current will be, most of the source current will be contributed by this source. So the current, as the current I, this is a series circuit, so current will remain same in the whole circuit, so the same current will be going through this 12 ohm. If I apply simple Kirchhoff's voltage law in this circuit, I will get the value of total current. See, if I start my journey from here, I will, at first I have to indicate the polarity of this resistor. See, the current is flowing in this direction, so the current, as the current is entering from this side will be positive, this side will be negative. Current is entering from this direction, so this side will be positive, this side will be negative, this side will be positive, this side will be negative. That's it. At first I will go through this whole loop. See, if I go from here to here, at first I will encounter this 99 voltage source and its negative polarity first. That means its voltage will be positive 99. After that, if I go from here to here, I will encounter this 9 ohm resistance, and as I encounter its positive polarity first, that means its voltage will be negative. Now how do we calculate the voltage drop across a resistor? Let's say this is our resistor R. If a current I is flow through this resistor, its polarity from this side will be positive and this side will be negative, and voltage drop across it will be current into resistor. See, the whole circuit is carrying the current I, so the current I will be flowing through this resistance, so voltage drop across this resistance will be current I into resistance 9 ohm. After that, I will encounter this 12 ohm and its positive polarity first, therefore its voltage sign will be negative, and I have to apply I into R. After that, I will encounter this 3.33 and its positive polarity, that means its voltage will be negative. How do we calculate voltage? I into 3.33. After that, I will encounter this 12 volt and its positive polarity, so this voltage will also be negative. Now if I simplify our above equation, I will get 87 minus 24.33 I. Therefore I will be equal to 87 divided by 24.33, and this will give us a value of 3.58 ampere. Okay, so this current, this 3.58 0.58 ampere current will flow in this circuit, and this current, that 5 point sorry and that 3.55 ampere current will flow through this 12 ohm resistor. Okay, that's it.